And we are live. On today's show, Javeria Khan will tell us how we can introduce GitOps into software lifecycles, mention some of the more popular open source tools and how they work in real-world production environments. But first, a short message from today's show sponsor, Bridge Crew. Security is a software problem that isn't being solved like one. That's why we started Bridge Crew. Our platform connects with your cloud infrastructure to quickly identify security issues. With continuous automation, you can always trust that you are in line with cloud security best practices. Start automating your cloud security with Bridge Crew for free. Okay, hi, it's Nancy here from the OWASP Devslop show, where we meet practitioners from the industry who come on the show to teach us something new. And if you're new here, please make sure to subscribe to our channel and note that all the important information that we'll discuss will be in the description box below. Let's jump right in. So our guest today is Senior Platform Engineer Javeria Khan. Javeria started off as a hardware engineer and then switched to software and systems. She's been a part of many infrastructure teams where she helped build and manage cloud and on-premises production environments with a special focus on scaling, reliability, automation, and operability. But again, before we start, I want to introduce you to my co-hosts for today. So first, let's meet Nicole Becher and Tanya Janca. Hi, Nicole, and hi, Tanya. How are you guys doing?
Hi.
Hi. So, GitOps. Familiar with the topic today? Not at all?
I do not know GitOps.
GitOps.
There's ops for everything though, Tanya, right?
That's true.
YouTube ops, GitOps, this ops.
Well, I'm thinking of the ops team that would work at GitHub, and that's probably not what they mean. Because I was like, awesome, they're coming. But I don't think that's what you mean. I think you mean the operations of like running everything with Git and maybe potentially some infrastructure as code.
I think you're there.
But it means that we need Javeria. Thank God that she's here. So we have another special guest. Well, it's a special guest presenter, guest host. You might be familiar with him because he was there last week. It's Renan. Let me bring him in. Hi, Renan.
Hello.
So Renan's a senior engineer, a great content creator in DevOps. He has his own YouTube channel. He'll tell you all about it. Introduce yourself, Renan, please.
Of course, yeah. So my name is Renan Diaz. I work as a senior engineer at Solid Build. And my work is a lot focused on architecting and building cloud solutions for clients, as well as implementing DevOps practice with security best practice in mind. I started as a software developer, more specifically developing mobile applications for iOS. And then I changed to front end, back end, and then for a couple of years now, I've been focusing a lot on the infrastructure side of things.
Awesome. Tell us a little bit about your YouTube channel, the content creation stuff that you do. It's pretty cool.
Yeah, of course. So I run an event which I call DevOps Dojo, and then this event is basically you form teams, and then you have to build a solution for a certain problem using technology. And then basically my channel, I record videos showing how to build the solution, and I'm actually gonna go on Twitch now to do live streaming to show how to build this solution for each one of the dojos. And as well, you're on the channel, you're gonna find videos with security tips, network tips, and this sort of things.
That's really cool. And we'll see more of you in the next few months because you'll also be a guest. So I'm excited about that. Okay, so let's get into it and bring our main guests. Hi, Javeria.
Hi, Nancy. Hi, everyone.
Hello.
So what do you have planned for us today?
So I'll talk about GitOps, but first of all, thank you for having me here. It's great talking to everybody and sharing what I've experienced so far. So basically, I'm going to talk about GitOps tools today and how to manage your infrastructure and some best practices.
That's pretty cool. Sounds exciting. Let me put your slides up.
Great. So I guess let's dive right into it. Let me talk about a bit about myself first. As Nancy mentioned in the beginning, I was an electrical engineer by degree, so I initially started off my career as a hardware IC engineer. And then I switched over to software a little over 6 years ago. But over these last few years in software, I've worked in multiple infrastructure teams as systems, SRE, platform engineering. And as you can tell, the industry has a few different terms for this domain now. So, but it's also basically all the same kind of work. But generally, the focus is always basically about building infrastructure for reliability and for automation and for operability and performance. I know we were just talking about what is GitOps, and everybody was trying to sort of pitch ideas. So you were a bit right. It does also include infrastructure as code, and GitOps basically means you're doing all your operations through Git, and Git is basically a way to source control, version control all your infrastructure or your code files. And you apply the same mechanism to your infrastructure. And that has like different benefits to it that I will come to in my presentation. So at the moment, I am a senior cloud platform engineer at Snowflake. I am a part of our cloud engineering org at Snowflake. Since we are a multi-cloud platform, my team is basically responsible for building and managing our platform in these multiple clouds. My more recent experience basically comes from managing Kubernetes clusters deployed on cloud providers such as AWS and GCP, and also on-prem environment. I've done that for a while as well. So basically, this presentation will mainly be focused on Kubernetes. I will go over a few of the couple of GitOps patterns and themes that I've used, the other stuff that I've used to optimize our workflows, and also some of my main takeaways from building and operating these clusters. This presentation is meant to be interactive, so feel free to ask questions at any time or stop me at any time if you would like me to go into more detail or explain something a bit more. All right, then. So getting started. So first of all, just to begin with, before I sort of go into the architectures that you can use and what GitOps things that you can use, let me just briefly define what it means and how you can use it. So as by now, you probably know, or it's actually more popular now in the landscape, but that term GitOps was first coined by the people of Weaveworks a couple of years ago. But since then, it has then gained much more popularity, with many tools now offering automation around operations and dev processes. But basically, in essence, the idea is that you version control both your infrastructure and your code, and then you can use a GitOps tool to compare that current state of objects in your infra to that desired state in version controlled. So this way, by automating the deployment of any kind of cluster changes, first of all, you gain reversibility because rollbacks are easier. You have that previous version and source control somewhere if you need to go back in time. Secondly, you get an audit trail, which is nice because everything goes through PR processes and you know who did what at what time. That is also great for like compliance exercises that your company may need to do at a certain point. And then lastly, you gain transparency because now there are no more obscure system type of changes that only a few people know how to do. But basically, besides the benefits of gaining transparency and reversibility that I just mentioned, in my personal journey, I've been working with Kubernetes for more than about 4 years now. And over this time, I've built many clusters on the cloud as well as in data centers on bare metal nodes. And every time you go through that kind of process and you design a new cluster, whether it's for staging or for production or for test, as engineers, we sort of tend to end up looking into how to optimize and automate these otherwise repetitive tasks and how to make managing those infrastructures that you keep building less painful and more secure. And GitOps basically has really helped me automate some of these otherwise painful management tasks, and it kind of brings together a better collaboration between all the different types of teams that end up using that infrastructure that you're creating. So using some of these tools can really help augment your entire software development and deployment lifecycle. Okay, so let's actually get into if you were using GitOps tools, and I'll go over a few of these later in the presentation, but like in a very general overview, this is what your sort of dev lifecycle could look like. So when you introduce GitOps practices and tools in your infrastructure, this is an example of all the steps it can help with. As you can see, I've sort of got like the numbering of the flow here. I'll go from 1, 2, 3, 4 the way the flow goes. And I also have the tools defined on top of each stage, which could possibly be used there. So basically starting with 1, developers basically do their pre-prod dev and testing on their local laptops. And then they use image building or app development tools to build that source code into containerized applications running either directly on their laptop or even in remote dev test clusters. Now, some of these tools can also help automate this process by iteratively syncing their local changes to the repo or also even to those remote apps running in like the test clusters. And then some of them also aid further integrated testing by providing port forwarding to the remotely running dev apps or even streaming remote logs back for them. A few examples of the tools that provide this kind of functionality for you is like Draft and GitCube and Scaffold. And then coming to the second part, so when all of this is done and tested locally, the code can then be pushed into production branches of code repos for PRs, which your CI system, whatever you prefer to use, the popular sources are like Jenkins and GitLab and CircleCI. So these systems will build and test your code for you again, and then eventually they will push the newly built images up to some kind of private image registry that you're keeping. Now, once those new images are now available on your registry, you can then have GitOps controllers that actually run inside your cluster. This is step 5 over here. So if you've got like a few different Kubernetes clusters, you actually run these GitOps controllers or these sync conversions tools inside of your clusters. And they watch your image registries for new images. So as soon as it sees a new image over there, it can update your remote apps automatically.
Hey, Javeria, just to interrupt quickly, there's a question in the chat, and I just want to get it out there already. It's a good one too, which is, why would you want to decouple CI/CD for security?
Yep, that's a great question.
The suggestion was possibly code scanning.
So yeah, I do go into more detail about this, but I'll briefly touch upon this here. You would want to decouple CI/CD because that way you don't have to sort of run your CI within your infrastructure. As you sort of grow your environments and your clusters, you don't want to have to put like a Jenkins or GitLab instance inside each different cluster environment or each different environment that you create. I mean, that becomes hard to manage. And if you're using some kind of cloud provided solution like CircleCI, that brings along different kinds of security and compliance sort of exercises where you have to sort of, for your CI to be able to touch your cluster to deploy stuff to it, you have to give it access. So for example, if you were in AWS, you would have to enable your CI to open a few security group rules for it to be able to talk to your cluster every time to deploy your application. And if you decouple those parts, your CI now does not need to be given access to your like production environments anymore. And you've got other stuff running, those sync controllers running in your environment that I just mentioned, and they automatically watch for new changes. So it's kind of like a pull model instead of a push model anymore, but you're more secure because you're not giving extra entities access to with your production environments.
Thank you.
So yeah, great question. I'll go into a bit more detail about this a little later because as I've worked on on-prem environments and I've also worked on like cloud-based environments, so I'll talk about how we moved from going into like CI, doing all the deployments into like that decouple model and how that helped security later. So as we were on step 5 in the diagram, those sync controllers were watching your registry for new images and they were updating your apps automatically. So your CI system is not touching your cluster anymore. The other cool thing these CI/CD systems can do over here is they can automatically also lint for new changes. So the kind of softwares that you can use here, the popular ones are Workflux, Scaffold, etc. But besides PRs that the developers push for like code changes, they can also push changes for the manifest that you run on your clusters. So the other kind of config repos that we keep here, we call them manifest or config repos. They keep your cluster components such as deployments and services and ingresses. And your sync controllers, in addition to watching for images, they can also watch these manifest repos for changes. So for example, if you went into like a specific deployment manifest and you changed resources or you changed some other kind of environment variable, those also get automatically applied for you through your sync controllers. So that CD system also watches your config repo. As soon as it sees a new change in your manifest, it'll do the linting for it. For example, if they were YAML, it'll just sort of quickly make sure that that YAML syntax is fine, that it won't generate any errors once you deploy it, and then it'll deploy it for you within the cluster. So So these are basically the system level changes that your sync controller will also apply for you.
Javeria, I've got a question around that. So for the config repo, is that something that is you generate automatically, or how does that work? Because when you start, you've got your code repo with all of your configs, but then once you deploy, is the Git operator put everything there in the config repo?
So you do that
you
yourself. You create your config repo. So think of it this way. When you create a new Kubernetes cluster and then you're deploying applications on top of it, now you've got like this web server that you've got running in different pods. You have to define the manifest, the deployment file, the service file for it first. And then those manifests for like the applications or the pods, those are what you put into the config repos yourself. Now, one of the main issues, which I'll go into more detail here, is as you scale your clusters, as your environments get bigger, it becomes harder and harder to keep so many different versions of your applications for so many different cluster targets. So what I mean here is that one web server that you might be running in cluster 1, now you've got that same application running in 4 different clusters, but they have slightly different variables in each. So for example, like the application endpoint values might be different, or you might have different resources defined for each of those applications in each cluster because, for example, one was staging and one was like a pre-prod and one was a prod. So because staging was not as scaled as prod was, so you were maybe giving it only like half a core per pod, but in your production environments, you think it was going to run hotter because you had more queries that it was sort of serving. So you might give each pod like 1 full core. So those resources that you define in your manifest, now you have to keep that many different versions for each cluster. This is where templating tools such as Helm and Customize and KSonic come in. So you create those manifests yourself, but then these templating tools help you manage multiple versions yourself. So yes, once you've created those files yourself, that sync tool will watch the files for you. So it doesn't create any of them for you, but it applies your changes automatically. So it's not managing your files, but it's applying the changes from your files automatically.
Right. Yeah, and I think there's a lot of people that they focus on the cluster security, but then sometimes they forget a little bit of the CI/CD security, and that's why it's good to decouple these things, right? Because then your cluster might be more secure than your CI/CD, but then someone tries to leverage the CI/CD to access your cluster and do some damage. Yeah.
Oh yeah, definitely. I mean, it's always obviously better to sort of constrain your attack surface. So the less amount of things that you can give access to your cluster, the better. So it's not even CI/CD, as we'll come to later. These sync tools, you can actually, they help you remove admin layer access for even like other developers. You don't want everybody going into your cluster and being able to like change any application they want to. You want to be able to define RBAC roles and different security profiles for different teams and the layer of access that they should be given, and putting like these kinds of sync tools where people aren't allowed to do manual changes anymore. That also helps in that regard. Okay, so moving forward. Now, as I mentioned, I've been working in this domain for like 4-ish years since I started working with Kubernetes, and for a while in one of my teams, I managed on-prem infrastructure for Kubernetes, and then also in a few other teams, I've managed it for like the cloud as well. So coming to the on-prem example first, a lot of these examples will actually be similar in both environments, but there's certain things you do slightly different for on-prem environments. So first of all, for like an on-prem stuff, this is where you would have like multiple clusters running on bare metal nodes, possibly in various data centers dispersed across the world. And this is sort of an example of how I've managed such an environment. So all infrastructure code, such as cluster components like the kubelet, the CNI, the etcd, etc., like the stuff that actually makes up the cluster, and the control plane stuff, as well as like any add-ons for observability or extra features that you add to your cluster, we kept them as Ansible templates, which we were using to build and maintain and update the clusters. I also have a few examples of tools here. So KubeSpray is an open source cluster building tool that uses Ansible, and you can fork it and you can keep a local copy with your specific playbook changes. And that source controls basically all your cluster components that way. And then everything can go through pull request approval processes before deployment to any QA or prod cluster, and you basically get repeatability that way. For every new environment that you create, so that set of playbooks you have through Kubespray, if you've managed to sort of pin down like the exact features and the exact version of Kubernetes that you want, you can just use that same set for every environment you create afterwards. And you also get an audit trail, obviously, because everything is going through PRs and you have all that like history in Git. CI, I say, would be pretty standard for both environments, like for on-prem and for the cloud. So basically, Jenkins and GitLab and CircleCI are like the popular choices here. The Kubernetes CD pipelines that I was using at the time were configured to sort of use Vault and Helm, and we had an internal fact management system to pull in secrets and server information for deployments during build. And then secondly, the other layer. So the first one was like the Kubernetes infrastructure layer that makes up your cluster. The second layer is like the applications that you run on top of your cluster, like that web application I was talking about. So those application manifests, like that deployments or the pods or the secrets or the services you define for each specific application, those were maintained as Helm charts. So those were like the ones that I was talking about for the config repos or the manifest repos. So you keep these manifests separately. You can also keep them together with the application code. That's one way to do it. But I've preferred to keep them in like separate repos, so they're decoupled from the code itself. And these manifests, you can use Helm or Customize or anything at this area, but these templating tools help you then keep multiple versions from multiple clusters. And in the case of Helm, you can build new app images from your code repos, and then you can get these deployed through the manifest as new Helm chart releases. It's also at this stage that you can then also add GitOps sync to the application layer, which is, like I mentioned, a convergence tool such as Flux that will continuously try and converge to the state defined in source control. But of course, the main challenge at this app layer is basically managing those multiple versions for multiple cluster targets. Now, there are various ways to do this, and I would kind of say that this isn't like a completely solved problem in this ecosystem at the moment. So templating tools, like I was mentioning, Customize and Helm are a few ways to do this. They both have their pros and cons, and I've used both in production environments. Helm is great because it's like one set of files that you can apply everywhere, but that file kind of grows vertically, because as you define more environments, you end up putting so many if-else clauses in there, depending on how many changes you have between environments. And Customize is also cool, but the thing with Customize it grows kind of laterally. So as you have even more environments, you end up creating even more files per environment for your overlay definitions now. I know I'm getting into like specific details about the tools, and not everybody will be familiar with them, but just keeping it at like a high level to explain Customize, we'll have like one chart version. So like one set of files for that chart that you're deploying. But Helm will. But Customize, it has this concept of like a base configuration, which is sort of your default configuration for your file. So for example, for that one web application, you would have a deployment file, you would have a service, you would maybe have like an HPA file, which is the horizontal pod scaler, like all the things tied to that one application. You would have this default version, but then as you had like 10 different clusters that were using the same application, but they all had like slight different changes. For example, the image would definitely be different among the clusters. The way Customize does this is you create overlay files. So there's that base version, and then on top of it, you create this overlay file, which has just the very bare minimum keys that the main YAML has, but then it defines that one difference, which is maybe the image, maybe the resources. And Customize has this magic built into it, where when you do like a customized build, it'll sort of merge both templates, and it'll figure out what the eventual version is, because it'll replace the values in like the overlay on top of the base version, and that's what gets deployed. But this is what I mean by a lateral expansion. As your clusters grow, as your like end targets grow, your number of files will grow, and your directory structure will keep growing with it. So I think it sort of depends on the end user to decide which I think is better for like their specific environment. Lastly, I know I keep talking about Kubernetes, but the GitOps ideology itself isn't strictly tied to Kubernetes. As you can see, it's sort of the idea is to version control anything. So you can apply this even like at a more widespread level, where I'll give you a few examples. For example, we were using GitOps to manage all of our like GCP infra through version control Terraform scripts that were then applied through BRs and Atlantis pipelines. Now, Atlantis is sort of this GitOpsy tool, which can sort of do a Terraform build and apply for you from the repo. This was great because this allowed like our multiple SRE infra dev teams to build out projects and to build out like internal components on demand in set predetermined ways, with that whole approval and review process handled within the same PR. So like all the approvals that they might need for like the new components in GCP that they were requesting, like SecOps approvals or like security or InfoSec approvals, everything would be tracked in Git, everything would be tracked in that PR, and as soon as that PR gets merged, they automatically get their changes in GCP. Secondly, for all other kind of on-prem stuff, such as provisioning and orchestration and config management, we did a lot of that through Salt as schedule state. So you can keep the Salt scripts also as source controlled stuff, and schedule states would run on top of your servers, pulling in new changes as soon as it saw them. And then coming to monitoring and alerting, this you can also keep in repos, and we had sort of alert manager rules and runbooks living alongside the Prometheus rules, and these were getting applied automatically by sync jobs running in like global Prometheus servers. Lastly, Kubernetes cluster logging. You can use something like fluentd config. We were basically managing this alongside all of our other cluster components with Ansible, and it was released likewise.
Quick question. The Prometheus Alert Manager, or the rules that you would add to Prometheus and you tie them to runbooks, could you just drill into that a little bit more? Like, how do you identify like a good candidate for that connection?
So let me understand your question more clearly. How do you apply each rule to each runbook?
Like, yeah, like if you have a runbook and you're like, I want to tie that to a Prometheus rule, so something's alerted. So I get alerted when something happens. Like what are those good candidates to like kind of thread that needle? Because I guess not all things in a runbook could be alerted via Prometheus. I guess there's only probably, I don't know. I'm just trying to understand a little bit.
Like basically anything you define within your alert manager rules will generate alerts for you depending on whatever like eventual alerting system you're using. We've used PagerDuty everywhere. And Prometheus actually has hooks for you to be able to hook up like external links to each alert. So if I had like this specific alert that went off every time I had this many 500s from my application within 5 minutes, and obviously it's like a Prometheus query that has to go, that has to succeed for it to be able to say, oh, this alert is valid, I need to fire this off. But when it fires that off, it also has like these keys where you can define external links, and those external links are your runbooks. Runbook is, everybody knows, it's like a playbook for what you need to do if that fires. Since we were source controlling it, so basically we also kept the runbooks and like the process of somebody who was like on call and they got that specific alert. They would get the alert, they would get the runbook link would be in it. You would just click it and then it would take you to the runbook. And for it creates onboarding for people much easier, because then they've got the automatic link and the runbook will open and it'll have steps of the stuff that they need to run or the servers that they need to look at for the specific kind of alert. Sorry, did I answer your question?
Yeah, no, it's a great technique for like, like really, easier troubleshooting, I think, right? Tie it right to like an event that happened. You've observed this happen. Here's how you correct it, right? Without like much emailing chaos. Yeah,
definitely. I mean, especially for me, for being having been on so many different infrastructure teams, a lot of the main onboarding energy and time is spent on bringing on new people to the on-call rotation, and you want to do that right because you want to sort of ease the load on the people already on call. There's no set way to do this. Every place has their own sort of like procedure that they follow, but it's great, and the best thing you can do is document everything. Like, I know it's not possible to sort of document every kind of thing that could break and every kind of alert, but at least you should have like main documentation for your like main more frequent alerts where people actually know what to do if something fires, and that if that information is easily accessible as soon as something fires, that's great, because then they don't have to go look for it and spend a few more minutes during an incident trying to figure out what went wrong and how to sort of solve this.
Yeah, it's great.
But the main GitOps point here is actually, so you've got Prometheus servers running and you've got these alert manager rules within your repos. How do you get them to like update automatically? And the other important point here is As your teams grow, as you get more and more application teams, each of them will be like responsible for a specific feature or a specific different kind of application running in your clusters. Now they will have their own alert streams because they know themselves best which particular things are like good candidates for alerts. They know which things should be alerted on. You don't want your infrastructure team managing everything. You don't want them like policing all the alerts. You want this to be more of a self-serve model. So for example, if a certain application was like really chirpy and it was going off at 2 a.m. and you wouldn't necessarily, I mean, as infra engineers, you wouldn't know that this was like just a harmless noisy alert. Somebody needs to maybe tune that level down. The application developers then can go and do that themselves. They don't have to wait for like an infra person to tune it for them. What they can do is like send off a PR to that alert manager repo, changing the query for themselves however they think is appropriate. And that PR process and that merging process automatically applies that rules to their Prometheus server. So that's where you apply GitOps stuff at that layer.
Right. So you track all the Prometheus alerting rules within GitHub itself, and they're all, yeah.
And anybody can change it. It just requires a PR. Yeah.
And so just coming back to the config repo, yes, just had one quick question. So how do you organize the repo in terms of the branches? So like, for example, if you have a cluster for different environments, do you keep everything in master, or do you have one branch per environment? How does the config repo look like?
So there's definitely a few different ways to do this. This is what I meant by this is the exact layer that becomes more and more complicated as you grow in size. And this is the problem that nobody's actually solved completely within this ecosystem. Every place has a slightly different way of doing it. I've done it a few different ways in different places myself. One approach is what you just mentioned. You can keep branches for every different target. The good thing about that is if you've got not too many clusters, I would say like less than 10, that's still fine. The benefit you gain from that is you don't necessarily need to use Helm or Customize or some complicated templating tool. You can just keep a different version per branch. So if I had 4 clusters, or if I had like a staging and then a cluster 1, 2, 3, 4, I would have a staging branch, and then I would have a cluster 1 branch and a cluster 2 branch, and I would keep whatever my manifest version for that branch was for that cluster was in that branch. Those sync controllers that I was running within the cluster, because I would have one sync controller per cluster. There would be one running in staging. There would be one running in cluster 1, and so on. Each one of those would be hooked up to that specific branch that it needed to watch. That's way 1 of doing it. Way 2 of doing it is you would keep the same branch. So you would have this one branch that kept versions for all of your 10 different clusters. And if you were using, for example, Helm, first of all, you would have one version of the chart, but then you would have this variable files. And that variable file would define depending on different variables. Now, if this was cluster 1, this is what the image tag should equal. If this was cluster 2, this is what the image tag would equal. Now, this is a very simplified example. In a lot of places, there are even more like deltas between clusters, or even if you had like different environment variables between clusters, or your applications were exposing like different endpoints, you would put all that in your variable file. And your Helm chart would reference that variable file. And depending on what cluster it would replace the files, and it would do the deployment for you. Now these tools like Argo CD, for example, it has support for Helm and Customize both. So it'll do those variable substitutions for you before deploying. The third way to do that was Customize. So you still have one branch for all your 10 clusters. But with Customize, like I explained, you have the page version, and then you've got like overlay versions per cluster. So you're keeping all these different like versions of files within the same directory for the same application. Just each file defines what the image should be for that cluster, so your directory structure is growing. So yeah, long-winded answer, but you can do it anyway. It really depends on your use case, and it really depends on your scale sort of layer. Every approach has its pros and cons and its headaches.
Yeah, I guess that will depend on how the Git flow being used by the team, right? Because one thing is when you keep everything in master, and then you do PR off of master and then come back to master. But if you have different branches, one per environment, then it might be a little bit challenging as well how to create PRs from which branch and merge to which branch, right? So I guess the flow being used like for Git is to be I guess a little mature for doing that.
Definitely. If you're keeping like different branches, you're actually offloading that complexity onto like the developers and onto our merge process. So you need to keep track of, okay, master is the version that all the staging clusters deploy to, and then we'll have like a separate branch that all the production clusters deploy to. You have to remember to sync master to production every time. So that's where I mean the complexity goes. It's really a trade-off depending designing how you think these things. You should definitely try these in staging first. Try the tools, try the workflows, see what feels better for your environment, I would say.
Yep.
All right, coming to my second example of working with cloud teams. So basically, this is where the majority of your infrastructure is on some kind of cloud. Let me sort of describe my experience of adopting GitOps there. So in one of my previous teams, we had like a couple of self-managed clusters in AWS. By self-managed, what I mean is that you're not using the cloud offering like EKS or AKS, where they sort of manage that, where they give you like a prepackaged cluster that you can use. With self-managed, you're actually building the cluster yourself on top of their compute nodes, and then you're managing the control plane as well and all like the cluster components yourself. Basically, it was at the point when we went from like a single production and staging cluster to like a few more is when it started becoming harder to keep all of them in sync. And especially for deployments that ran in multiple clusters at like the same time. So while we had automated our CI/CD pipelines to deploy new code versions to all intended clusters at the same time, there was still that problem of keeping the deployment specs in sync. So basically, like I mentioned before, things like the resource requests or like the replica counts or even like the image versions between clusters. And even more critically, we still had the odd issues where one deployment could go out of sync with the rest because somebody had accidentally modified the image it was using in that cluster, or they were testing something like in production and they forgot to revert back to like the image that it was supposed to be using. And while these kind of one-offs were like easier to manage in single clusters, they really quickly became a nightmare in like multiple ones. The talk around GitOps was just starting at the time, and that's when I sort of decided to give it a go and see if it could help sort of solve some of our operational issues. And the security aspect that I was mentioning before, so this is where basically our CI/CD pipelines were already automated to deploy directly to the clusters. And they did this by pushing new images to the registry and then updating the deployments to kubectl commands. We actually had automation around punching security group holes every time to our clusters to allow like the Circle CI system to go into the cluster to deploy new changes. So basically, connecting to the cluster every time to deploy new applications, it's not like the greatest security practice. But once we introduced Flux, that CI pipeline, they were simply changed to, instead of like touching the cluster every time, they were changed to simply update the image version in another config repo that was keeping the cluster deployment YAMLs. So these later config repos were like the ones that Flux was hooked up to and that it washed. And the good thing about this process is that the CI system now didn't need to be given access to the cluster anymore. And you also don't necessarily have to like bring your CI in-house and run it yourself, which obviously becomes more complex as you create more clusters over time. So these self-managed cluster states that I was mentioning, they can be kept in tools like kops. It's like KubeSpray, but this one is popular for like building clusters on top of AWS and on top of the clouds that you want to manage yourself. You can configure it to keep the state in like an object store such as S3. CI, like I said, is pretty standard. Janca and Circle CI GitLab between on-prem and cloud environments. So you can use any of these. And coming to like the second layer, which is application manifest. In the cloud environments, I have more recently used Kustomize. You can use YAMLs per cluster branch, which was one way we were just talking about, or you can sort of use like the customized way of templatizing each different application within the directory structure, and that sort of expands that way for you. CI/CD, for the CD part, we were using Argo and Flux for the linting and the deploying of the manifest stuff. So the CI systems were pushing the YAML changes to the config repo. So instead of touching the cluster, it would push the new image to the registry, and then that new image tag would simply be updated in the manifest repo. And since Flux was watching the manifest repo, or Argo is watching your manifest repo, it can just update your app that way. Lastly, like the previous example, we had a few things that we had homegrown solutions for, which I would sort of also categorize as GitOps. So example was like the Prometheus channel in the on-prem environment, same thing over here. We were keeping the alert manager rules in the repo, and we created like these client agents on the prom server that watch the repo for changes, and then it used prom tool to validate new changes as soon as it saw them, and then it would apply them for you. This last one is obviously a really good example of improving collaboration as you scale, as you get more teams, and you can, and each of them like get their own dedicated clusters, and they want to manage their own monitoring alerts. So let me just talk about a few of like the popular tools. This is by no means like an exhaustive list, and this is like not all of the tools in the landscape at the moment, because there's quite a few of them now. These are just ones that I've had an occasion of using, and ones that I think are quite popular at the moment. So when you're evaluating new tools to bring into your environment, some of the main things that you should look at are a few of these. First of all is dependencies, because a lot of the main time and effort spent is even though we like something and we bring it in, we have to convince the other dev teams to adopt those approaches. So look at the learning curve that tool has. How easy is it for people to adopt? How easy will it be for you to sort of have the usage of it adopted more widespread in your organization? Some other like good features of sort of between the tools is, does it handle source control? Does it have iterative development support? What that means is people are like doing local changes, does it automatically sync the remote applications for you from your local changes? Logging, how good is it with logging support? And then stability, and what version is it on? What kind of community does it have? How easy is it to get help if you need it? And very lastly, and most importantly, is it recommended to be used in production? So while a lot of these tools, they will have common features, but they're not exactly interchangeable. The innermost layer, like I have this diagram here, are templating tools, which I've talked about a few already, Helm and Customize. They make it easier to roll out different versions for different clusters. A layer above this is app development tools such as Draft and GitCube and Scaffold. These help you in the building of an application and up to running it like in the cluster. And very lastly is like the deployment tools like Flux and Argo. These are the ones that you are meant to use in production, and they also help to keep things in sync with the source control. So coming to the actual tools, I'll give you an example of like one tool at each layer. Coming for the very first one, Draft. This one's by Microsoft Azure. It's an open source tool. This is basically used for like the local dev workflow. It's not meant to be used in production. And this is sort of, it targets like the inner workflow of a dev when they're still writing applications for Kubernetes. The main strong point of this tool is it supports many of these popular languages like .NET, Go, Node, etc., etc. It doesn't have a lot of dependencies, but it's very well integrated with Helm. And I would consider it sort of stable. They've got a 0.16 release. This doesn't automatically update the remote changes from Git, but it does automatically update the remote changes you have running on your laptop to, like, you can hook it up to a remote cluster that way. So you use it to deploy your applications to a Kubernetes dev sandbox, and you can then have it accessible using Draft Connect over a secure tunnel. Second one, so we're coming a layer above, which is the deployment layer. This one is cool. It's interesting because I kind of think of it as a predecessor to Flux and Argo, but this is an app deployment tool. It was created by Hashira. It's sort of a way to deploy Docker image on Kubernetes through a Git push. It runs entirely on the cluster and there's no CLI. This one has the least amount of dependencies to use. And basically the way it does this is there are three main controllers running in your cluster, but basically what it does is it's got this remote CRD, which defines what should happen when a push is made to like a remote URL. It's the same concept of like a webhook that Jenkins has. So GitCube is the other controller, which actually builds your Docker images and it updates the deployment. So whenever it sort of detects a change in code on like that remote repository, it'll automatically build the image for you, and then it will apply it to the cluster itself as well. Coming to the next layer, which is the deployment one as well, these are the most popular ones. So these days, when you talk about GitOps, they're synonymous with these two tools specifically. Flux is by the people at Weaveworks, and Argo is by the people at Intuit. These are both deployment tools. These are the cluster synchronizers that you run within your cluster. They support Helm. You don't need Helm, though. They also support Customize. So both of those templating tools are supported. These are very mature releases. I think Argo has like a really nice UI. It gives you nice visualization of all the apps that you hook it up to, and it can you can easily go within the UI and also define if you see if something's out of sync, and you can do your operations that way. Flux runs entirely as a pod within your cluster. It doesn't have a UI, but it's like it's got like a minimal setup, and it's not heavy at all. So you can also use that as an option to do your syncing. The cons here is scaling is an issue. We were talking about sort of multi-target management before. So if you've got different controllers, okay, so both of these actually do have the option of doing a federated kind of deployment sync where you can have one Argo instance that's hooked up to multiple clusters. But I've always done it in the way where you run a separate Flux and Argo instance per cluster. It's just easier to manage that way. But if you had that one instance that was managing multiple clusters, you would have to hook it up to different branches within your Git repo, and that becomes slightly more complicated. Also, scale is an issue there because scaling then is not easier, and you have to use some fancy RBAC and some fancy namespace limiting options to get that to work. The other con with these tools is rollbacks are not possible within the tool. I mean, they're not automated. And they're not straightforward. So if you had something that you needed to roll back, you have to go within the UI or you have to go within Flux. You have to de-automate it for a little while. You have to then do your changes in the cluster. And then when you're ready again, then you re-automate it through the UI again. So that's slightly not straightforward, I would say. The workflow is similar to that very first diagram I showed. You've got this dev. Dev commits some code to the repo. It also triggers like a build and test within the CI, which pushes new Docker images. This Flux CD controller that you have running within your cluster is watching your registry, and it's also watching your config repo for changes. If any of these are found, it applies the changes to your cluster by talking to the API. And then your dev now does not have to directly access the cluster anymore through kubectl apply. One thing I touched upon before but didn't go into too much detail is when you're bringing up new clusters, it's really easy to give everybody admin access. So you basically allow everybody to go into the cluster and do any kind of operations they need to. They can update their own apps and they can do whatever. But as you scale and as your like organization grows, you really want to put more security controls in place. So this is where this comes in handy. Now you know there's a process that does a rollout for you, and you know there's like a tool that's managing all of that. You don't necessarily have to allow people to be able to touch things directly anymore. So once you put this kind of tool in place, you can then put in more proper RBAC profiles for your different teams, and you can allow or not the levels of access they need to have. And then they know that if they need to push out new changes, there's a process that needs to be followed. They push PRs, they wait for that to get merged, and they wait for that sync to happen.
Javeria, just before you proceed, there was a question in the chat. So just a comparison between, the GitOps process versus the GitLab features. I'm not sure if you're aware.
So GitLab is a CI tool and a CD tool. GitOps itself means syncing your changes directly from the clusters. So GitLab is basically just CI/CD. I'm not familiar with any GitOps operation that it might do. Please correct me if I'm wrong, something I haven't seen myself, but GitLab is something you would do to define your pipelines, to build your images, to push them up to the registry, and also maybe to do deployments if you wanted to. But I wouldn't use it for CD. I would use Flux or Argo for CD, because then your GitLab isn't touching your cluster. It isn't accessing your cluster to do the CD part. You've got that controller doing the CD part for you. So you're decoupling the CI in GitLab or whatever you use from the CD that's actually happening from within your cluster.
Yep.
There's another question in the chat. This is regarding Flux or Argo, do they support the dry run option to validate things
They
before
do,
committing
yes.
any
Flux
changes
is
to the
completely
cluster?
CLI because it doesn't have a UI. It has a Flux CTL CLI command that you can use to do all these kinds of changes, and Argo has something similar as well. I'm not sure you can do a dry run through the UI. The way I've usually followed the UI thing is I can de-automate something for a little while. You disable the sync, you go into your app, you can point your app to like that test branch, because each app can point to a separate branch into a separate repo. So that app you have in Argo, point it to your test cluster, and your app will get automatically updated to that test version. It's running in the cluster, you can play with it for a little while, and then you're sure that it works. You automate it back so that it goes back to the master version. And then you can merge your changes that way. So that's one way of doing that. Slightly not straightforward, but yeah.
Cool.
And yes, dry run options are supported. It does show you all the changes that it would do if you were to be able to enable it. Okay, the very last tool is Scaffold. This one is interesting because it basically does everything that all the other tools do. So you can use it for building or pushing or even deploying your apps. I'm actually going to go to the diagram here. So it's similar to Draft and GitQube, but it's much more flexible because it's automated and it has iterative support. It can do automated updates to remote from source code. It doesn't have a lot of cons. This is a very well-rounded tool. This is by the people at Google Cloud. And you can basically use any language within your pipeline for it, but it has, you can also use kubectl Helm, and you can also use it at the last sync place where Argo and sort of Flux are popular at the moment. But basically, you can insert this tool, or you can use it at any stage within your build and deploy pipeline. So lastly, I've sort of given you an example of each layer and what kind of tool it is. But the main points that they get, or sort of my review of them, is the main features that I look for. First of all, ease of use and the community and support. I think Flux Argo really win here because they've got a community. They've actually got their own Slack channel, and it's pretty active. Even if you're on the Kubernetes Slack, they have their own channel there. And there's always people like discussing different approaches of how they're doing it in their environment, or you can always ask people questions, and it's very crowdsourced. And even if like the official team isn't around, somebody else will be there to answer your question. Weave has its own Slack as well. They have a very focused GitOps sort of thing there. They've got a few channels. There's people talking over there. If you've got an issue with like any of these tools, you can discuss it directly, and the developers of that tool are there, and they will usually answer your questions as well. I've also like opened issues in the past, and I've seen them get resolved like within half an hour. So they're always very responsive. If there's something that's not working for you, they will respond directly to like the GitHub issues immediately as well. The other ones are obviously Draft and Scaffold because it's Microsoft and it's Google, and the bigger corporations, I suppose, have more. They've got more resources and more people available to sort of maintain these tools and these communities for you.
I have a question.
Yes.
So someone asked if you could please program a demo for them, but obviously we don't mean right now. But you did a talk at KubeCon, and I'm wondering if that talk, if it had some sort of demo in it, and if there's a recording, if we could share it with our audience.
It did not. So all the talks I've done up to now have been very, there's always some material to cover, but that's something we can do in the future. Yes, a demo would be nicer, but also I would like to know what kind of demo would you prefer, because there's so many tools. Is there like a particular one that people want to see in action?
Okay, so there's another question. Can you please talk about the privilege that Kubernetes requires for Flux Argo? So particularly if we want to limit changes to specific namespaces, for example, what are some of the good practices?
Yeah, definitely. So within like Argo, you define projects and you tie them to like RBAC roles. And then when you define your applications, each application gets tied to a specific project. So certain projects can have more widespread like privileges. Like I have this one project which is called admin, for example, and that project has like more things that it can do. And when I create new applications, if I have like cluster level applications such as like the cluster autoscaler, where I've got like cluster components that I'm managing through Argo, I add them to that admin project. And then when I have developers deploying their own like applications, like their own code, I create separate projects for them every time, and that application gets tied to that one project. And then that project has a very limited set of RBAC roles and very limited set of cluster roles and things that it can do. It's projects are also namespace, so you tie every project to specific namespaces. You would say, I have this one specific namespace, I'm tying it to this one specific project in Argo, and that one specific project is tied to like the only 2-3 applications that this one team owns. So they're all constrained within their same namespace. So it's basically just a mixture of cluster role bindings, cluster roles, those RBAC things that you define, the project, and then the applications that use those projects.
Cool, thank you. Those are all the questions from the chat.
Great.
I have a follow-up question on that. It's more of a security question. So basically, if you're, let's say you compromise your CI/CD tool and CI/CD doesn't have access to the cluster, so in that case, people wouldn't be able to deploy, right? So whoever accesses CI/CD wouldn't be able to deploy anything unless they have access to the config repo, and then Flux or Argo would pull up those changes. But what I understand is that Flux has a key, a private public key, and then you put the public key in GitHub so it can pull the code for you. But what's the security around the private key for Flux? So do they encrypt on disk, or if someone compromised or the cluster is compromised, is someone able to get the private key and pull code, or how does that work?
So as far as I'm aware, I don't think they bake that key. So what I mean is it's not visible if you have access to the cluster. So Argo and Flux themselves, they run as pods on the cluster. And you do have to use like deploy keys for it to be able to access your repo to deploy stuff, or for it to be able to watch your registry. But those keys, you can encrypt them, and I believe you can keep them in vault, so they shouldn't be directly accessible from the pods themselves if somebody does have access to the cluster that way.
All right.
All right. I see we're almost out of time, so I'm gonna like just go really quickly for the last 2 slides. So yeah, outside of ease of use, its stability, Flux and Argo would be considered pretty stable because they're pretty popular. They are being used in production pretty commonly now. Some special mentions here is, first of all, when I started using these GitOps tools, they did not have support for canaries and blue-greens and like special kinds of deployment models. Flagger is something that the Weaveworks people created, so you can use this specific tool in addition to Flux or Argo, and this does like these special kinds of rollouts for you, like blue-greens and canaries, and it's got like nice functionality on that side. Another special one is Pulumi. If anybody's familiar with Terraform, this is sort of like a new take on Terraform. So it's infrastructure as code. And since Terraform has its own like special kind of language, Pulumi takes this a step forward by you can actually use real coding languages to define your infrastructure components. So you use like Go or Python or whatever to actually define your infrastructure that way. And you can keep these files in source control. So it gives you that sort of audit trail kind of stuff on that layer. So very lastly, you've found some tools and you think they're great and you've tried them in your environments and you really want your teams to adopt them. How do you go about this? So in my experience, collaboration obviously between dev and ops teams is very important for a successful kind of GitOps culture. And I've learned that the biggest challenge in introducing any kind of new processes is in convincing people to take out the time to learn and to adapt to it. So even when it's meant to eventually optimize their daily workflows, it can be very hard to convince other teams to take out that initial time to learn and to also change their current workflows. And basically as operators, what we can try to do is keep the delta at their end as minimal as possible. So obviously the ideal is push button operations. But what I mean by that is try to automate all of the things as much as you can so they don't have to sort of learn so much to get used to the workflow. And also by really socializing new designs and processes can help. So this way you can incorporate user feedback early on. And if I take like the Flux example, we basically just had to socialize that people weren't supposed to edit things directly in the clusters anymore. And as any changes they did would get reverted by the sync controllers in another minute or so. And then they were basically supposed to create pull requests in the config repo, keeping the manifest, and they weren't supposed to touch the clusters directly anymore. The very last second point is important. It's basically the way to convince teams to adopt this is by socializing how their dependency on admins will decrease. So, you know, with GitOps tools, the changes in the infra can roll out and roll back through Git merges. And that way you don't necessarily need to ping that main admin on vacation, which is usually the case in like startups, to roll out special changes or to roll back like a broken build. And in extension, a main attraction for like the management layer folks is that as you cycle through employees and you also reduce the dependency on like single employees with all that special infra knowledge, which we kind of also refer to as a best factor. All right, and that's it for me. So any more questions?
Yeah, there was one more question in the chat. Can you just clarify what is blue-green deployments?
Right, so there are special deployment models where you've got this sort of pool of servers. For example, say you have these 100 pods running your application, and you've got this new version that you want to roll out into production, but you don't want to update all 100 of them at the same time, because even though you've done testing at many stages before, it's still a good idea to roll this out slowly. So what you can do is you can create 2 different pools of images. You can have 50 of them running on one, 50 of them running on one version, 50 of them on the other. So what you do is you roll out one version first, and you make sure that it's okay, and then you can roll it out to the second version. So you basically, Istio and load balancing things come into play here, but what you basically can do is you can switch traffic between these different versions. So when you're ready to go live with the second version, you can switch from your blue to your green, for example. That's what it means. Canary is a similar concept where rolling it out to those 100 servers, you don't want to do that at the same time. You do that out gradually. So you like roll out a few and then roll out a few and then you roll out a few. That's what Canary is. Or you sort of roll out a few and then you watch it to make sure that there's nothing wrong. You've got like all these automated controls in place that are watching like the error codes and everything and like the latency on your application, and everything looks nice and happy. Then you roll it out to like the full fleet then at that point. But these are called advanced deployment models.
Great. Thank you. I think there was one more. Renan?
I got it. So
All right.
someone was asking, so first of all, they said, you know, could you make a demo? I'm like, well, we don't have time to do a demo today. And so the person came up with, so they said they have a cool idea for you. It's a big idea though. Build for us a full pipeline process from code to deploy, and she is free to choose the tools. Well, that's very generous, Mohammed. Allow her to choose whatever she wants. But
you know what I can do? I can do even better. So the developers of these tools, like Stefan does Flux, they've got a lot of good talks online, recorded ones that do this entire workflow for you, and they demonstrate how to go from git push to merging to actually deploying to your cluster. And you can see these applications and these tools in action over there. So I can find some of those links for you. And I'm sure they do a much better job of describing that than I do.
awesome. Maybe after, because we'll probably share, you know, some links to Twitter and put some other links. Perhaps if you feel up to it, you know, you could put some of your favorite talk links in the comments below for the video, so whoever watches this then can be like, oh, these are her suggestions. If she loves this talk, I bet I'm gonna love it.
Sure.
Coming on our show.
Thank you for having me.
Yeah, thank you. This was great. I learned a lot. Sounds like you've been into Kubernetes world for a really long time. I'm pretty blown away.
Yeah, it really shows the depth of experience you have with all those tools, and you know, the question on the fly that you were able to answer. That was really, really impressive.
Yeah, Kubernetes, I mean, it's hard to avoid no matter what domain you're in.
For 4 years, yeah, it's great.
Good.
The people in the chat agree that you were great, just so you know. There's many of them being like, this was quite good.
Thank you. Appreciate it.
I'm getting private messages on my phone saying how good the talk is. We've had questions of people wondering where to follow you. So we shared Twitter. If people want to know more about you, follow your work, what where do you want them to? What do you want them to see, or where do you
I'm
want
not
them to follow
super
you?
active on social media, but Twitter and I suppose even LinkedIn would be the place to follow me, or if anybody wants to reach out, that's where you find me.
Perfect. Excellent. And I know you have a few talks at KubeCon as well. So I think just looking up your name on YouTube, and
Yeah,
you'll
I should
find
do it.
a lot of your work. It's awesome. Awesome. Any last word from my guest, my host, my co-host, I guess, before I talk about what we have planned for next week?
You know, I'm just going to talk about gardens, so you should probably just continue.
Well, we can, mention quickly your new book and how everybody needs to pre-order.
I wrote a book, and it's called Alice and Bob Learn Application Security, and I am so excited, and it's for sale on Amazon, Barnes & Noble, like every other place. So look online for Alice and Bob Learn Application Security, and that's me with the great big purple cover and the two awesome people, Alice and Bob, on the front. And basically it is a textbook written in plain language with fun stories, and things happen to Alice and Bob's. They have lives, they have health conditions, and it shows you how the security decisions we make affect real humans. But it's still a textbook, so expect a textbook. Yeah, I'm pretty excited.
Awesome. And since we're plugging stuff, we'll mention again Renan's work. I guess the dojo that you're working on. You explained that in the beginning, but what do you have coming up this week?
I'm gonna basically be teaching Nomad on Twitch. So last week we had Dojo. Going through the basics of Nomad, deploying an application to Nomad, which is like Kubernetes, right? It's from HashiCorp. And so on this Twitch live stream tomorrow, that's going to be around 6 p.m. here EST. And so I'm going to go over the challenge, deploying applications to Nomad, doing service discovery with Console, doing load balancing with Fabio, and all this sort of things. So we're going to build a solution on Nomad tomorrow together.
Exciting stuff. What about you, Nikki? I have nothing to plug except continue watching the show.
I do
you
not,
have anything
not at this
to plug,
time.
Nikki?
Just work, head down work. Yeah.
Not at this time. Excellent. Good stuff. So let me show you what we have planned for next week. Next week we have Marina Seago. I hope I pronounced that right. She's for Checkpoint. We're going to talk about having a healthy posture in the cloud. So same time in a week on Sunday on the same channel. So please subscribe if you're not already, and get your notification for our next show. And we'll see you next week. And that's all we have. Thank you so much, Javeria. Thank you, Renan. Thank you, Nicole and Tanya. And I'll see you all next week. Don't go away right away, Javeria. I want to talk to you before you go.